Recently on the channel, I was looking at repurposing some STM32s to make new Piduk programs. And to test to see whether they were working or not, I just had a quick little program on the PFS 154 here, which changed the traffic light according to whether or not a button was pressed. So the button's pressed, it goes from yellow through to green, and then a few seconds later back again. So yeah, very simple program. And I was just wondering at the time, I wonder if you could do that with a few other different processes. I mean, at the moment with the PFS 154, I don't know an awful lot about it. So basically what the code's doing is it's just checking over and over again, is a button press, is a button press, is a button press. So that uses a lot of, power, which you wouldn't necessarily write code like that for this simple purpose. It works, but it's not very sophisticated. So what I did then was I made an A-Tiny13 version, and I'm a little bit more experienced with the A-Tiny13. So what I did was actually coded an interrupt. So what this does is that this program just sits there and it sets it to red, but then the process is actually asleep until it's interrupted via the button. Now, it's not that you can't do that on the PFS 154, it's just that I don't know how to at the moment. So that's a little code exploration that I've got ahead of me. But in the meantime, the A-Tiny13 version works fine and uses a lot less power. So then while I was mucking around with that, I thought, well, let's go a little bit further and let's try, this is an ESP32. And the ESP32 has got a lot of different characteristics, but one is that it's got low power options, it's got Wi-Fi options, it's got Bluetooth, and it's also, and I don't understand this in the current climate, but it's also quite cheap. So it's not unusual to get these guys coming in for sort of $3 or $4 Australian dollars, which is pretty good. So what I've done with this one is that I've just coded up pretty much with the same code that the A-Tiny13 had in it. So it just has the traffic light showing red, and then on demand, it goes to green and then back again. So not very sophisticated, but proof that I can actually talk to this, which isn't easy. There's I go via the Arduino IDE, and maybe that's not the best way to do it, but there's a lot of mucking around to get this going. This is one of the original ESP32s, almost like it's called a development kit. So yeah, I've had that one for quite some time. But then what we could do is we could actually go via, for instance, Wi-Fi. So there's no button on this one. So I've still got my three connectors here, red, yellow, and green. But what I've also got is, let's see if I can set this up so you can see it, is it's actually running a web server. So there's a web server running in here, and I've connected up to it. And when I press green on here, it actually enacts that light changing code there, and then goes back to red again. So yeah, not such a bad thing on demand this time, but over the over Wi-Fi. But of course, it may not always be that you want to change things over Wi-Fi. You might want a Bluetooth version. So what I also did was I just took delivery of another ESP32. Here it is. And this one's a bit of an interesting one. So this is the ESP32 C3 development kit. And yeah, so I didn't really know an awful lot about it, and it actually proved quite interesting. I mean, firstly, when connected to the computer, if I wanted to do any debugging over serial, as soon as I put the serial on, the whole device would shut down, which is extraordinary. And it took a fair bit of searching online to find out that there was a couple of lines buried deep in the boards.txt file that I needed to change. I mean, why wouldn't that be changed anyway? So I need to change true to false, and then the serial connection works, so I could actually do some debugging work. You'll see that I don't have the three LEDs because there's an RGB on board. In some versions of this, the RGB is an addressable RGB, but this is just a straight RGB with pin definitions of 3, 4, and 5. And that took a little while to find out as well. And then trying to get PWM going through that was proving quite difficult because this uses its own version of sort of PWM. So analog write, for instance, which would make sense, either isn't enacted or has been superseded or what have you. So I'm sort of undecided about this. I I find myself attracted to these bizarre incarnations. I mean, the other two, worked fine off the bat, no dramas whatsoever. And but this guy was stubbornly resisting programming. In the end, and after a lot of mucking around, I was able to connect to it and to program it. But then I struck another problem. These guys use Bluetooth. These uses Bluetooth Lite or BLE. Probably good, but again, all sorts of new libraries, new routines, etc., etc. So I've borrowed pretty heavily from the internet to get this to go. So let me just connect up to it if I can. So I'm just going to find the device. There's a traffic light changer and connect up to it. So it says it's connected, and then if I press green, then it goes from yellow to green, back to yellow, and then back to red again. So yeah, it definitely works, but I would have liked PWM changes on there instead of just, well, basically to get yellow, both the green and the red lights are on full blast and the blue isn't on at all. So it's sort of working, I guess. And definitely via Bluetooth, and that's all terrific. This one via Wi-Fi, this one via a button. So I suppose what I've done this for is I'd like to put a few more of these devices around the place for monitoring and automation. And they can talk to each other. They're pretty low cost. They've got heaps of memory. They've got great processing speed. They've got Wi-Fi, they've got Bluetooth, they've got everything. So I'm really keen to get involved. They've sort of been sitting on the back shelf for a while, but I think it's about time to bring them out into the light. That's the circuit working for this week. See you next time.